the week. And I'm trying to end on a really good note. And you guys hear me say this all the time. It's easy, it's easy. And some of you get mad at me because you tell me it's not easy, and I just think it's easy. Um, so I understand your frustration as far as that goes, but you have to admit, so far, man, this was kind of easy. All right, you have to admit that. And the only problem is when I say things are easy, sometimes kids relax and they may not do all the homework, or they, take a break, or not put the effort into it. And some of you need to put the effort in because your grade is in the balance here between A minus, B plus. All right, so you don't want to drop down because I'm not changing your grade. Okay, so and no amount of crying is going to change it. So um, the good thing about St. John's is the only real thing that high schools see is your what? Semester grade. Very good. So if you get an 89 and a 91, that means you have your A minus. Does everybody agree with that? Sometimes I think it's good for you to make a B to motivate you. Because some of you guys I don't think are working as hard as you can. Not sure that's true, but sometimes that's the way I think. So we have today 5.5. 5-4 is indirect proofs, which we never do because they're never on any type of SAT or ACT. They're just not. So I got rid of that section. Then today we're going to do 5-5. Tomorrow we'll do 5-6. Again, super easy. Today there's a couple little proofs, but minor. I don't even think I put a proof on the test. I'm not real sure yet. But I just wanted to show you. Thursday and Friday should be really nice for you because it's just IXL stuff. And the reason why I did that was because if we start a new chapter, we won't get that chapter done until after we go to what? DC, right? So it'll be kind of dumb to start a new chapter and then, So we're going to do some IXL on Thursday and Friday that has to do with this chapter. So everything in this chapter we'll do on IXL. Plus it'll kind of help me evaluate how good the IXL for this. Geometry IXL is not as good, I don't feel like. Especially like I looked at the proofs and they kind of do proofs a little bit differently. They call certain things a little bit different. So it wasn't great. So if I'm not mistaken, I think our test will probably be on Tuesday, all right, for this chapter. So those of you guys who are interested, all right, probably Tuesday, I feel like, is when our test is. And then we'll do something Wednesday, Thursday, and Friday. We'll start something, or maybe I'll show you. Actually, I think what we'll end up doing is doing like a bunch of SAT problems with all of the geometry. Because again, guys, I really would hope some of you guys would continue to try to take the SAT again this year, even if you took it again last year, just because you want to see how smart you're getting. All right. And I think it's a good reflection of you, all right, good indication of how you're thinking, because the SAT is more, not reasoning, but there is, a cumulative thing that I think is important for you to practice. So that's the game plan, all right? So we'll have one more test, then we'll do a bunch of SAT practice problems, and then we'll have a nice time on our trip because the following Monday is a holiday. And then we go on our trip on that Tuesday morning. All right. So again, please do well on, even though I'm saying it's easy, do your work. All right. You have to do your work to make it easy. All right. Now let's go ahead and flip back, and I will show you the solution since I didn't post them. And like I said, somebody please just send me an email. I check my email probably every 45 minutes. Especially because it's on my phone, and every time an email is sent, it just pops up on my phone, so I can see. So if I forgot to post something, you just tell me, and it just takes a second to post things. All right. So today we're doing 5-3, the solutions. So what I did down here is you can kind of see the solutions. So did anybody want to take a look at a specific problem here? All right. Let's look at 5-3.
Well, not here, but like on the back.
Yes, okay, so first thing I want to do is, before I move, is everybody okay with the first one? Right, and if you need me to blow up on a little bit, if you want to just touch, if there's a problem, yes.
2.
Good for you, kiddo. 2, what? Now, so I always try to tell kids, I think the easiest thing, measure less than 9. So here is 9, right? So what I want to do is, I want this triangle, do you agree with that? 7 and 6 would be the remote, right? And then this angle right here, and this angle right here, which is a little surprising, but that's also remote, correct? And then angle 2 and this angle right there are remote. Does that make sense? Those are the only ones. All right. Yes, sir.
Number 3, why would it 7 and 8?
Let me look. Let me erase now, because sometimes if I write, it's not. So we want greater than 5. So you see what I did? Good. All right, that's what I'm asking you guys. I'm not asking you to be right. I'm asking you to check your answers and verify your results. Right? That's what you're doing. Verify your results. All right, and if you're good, you're going to be good on the test. If you're not good, you should figure out why you're not good right now. Good. Number 3. Okay, now listen, remember, it's what we talked a bunch yesterday, which I didn't explain very well, because everybody had the question. So I'm going to say it one more time. This angle 9 is obtuse, right? And angle 5 is acute. So I would automatically say 9 is greater than 5. However, we're talking specifically about the exterior angle and the remote interior angles. You with me? Because I was trying to say yesterday, 9, I could make the triangle look like this. You see what I mean? And then it would be acute, and 5 would be the obtuse now. You see what I'm saying, right? All right? So that's why. All right. Go.
On number 5, there's no angle S.
Well, I'm sure they meant,
E.
yeah, I'm sure. Thank you. I'm going to correct that right now. So that should have been P, right? All right. Good job. Thank you. All right. Does everybody agree that's kind of easy, right? Kind of easy. All right. So here we go. Anybody? Anybody? Anybody?
I did understand how you not 17, but like 9 to 6.
Okay. So let's look at it. Let's look. Use the figure of the right to determine the relationship between the lengths of the given side. So you want me to look at 15?
I just kind of wanted to see 9 through 6.
Oh, okay. Okay, let's look at 9. All right. Now, again, the reason why these are hard is because I think they're overlapping triangles, correct? Right, I think that's part of the problem. Okay, so I got to highlight QRW. All right, so this angle right here, and then RWQ. I'm talking about this right here, right? Now that one, I feel as if you should be able to do that, though. Well, but you're just looking at the one triangle. So sometimes I'm kind of lucky because I can just do that, right? You see what I mean, right? And now you can see that opposite the larger side is the larger angle.
So all it is just the measure is one triangle, like the measure of all of it is more than the other.
Well, because here, let's look at this. Because this is what, 47, and this is 45. 47 is greater than 45, therefore W is greater than R. Right, because the relationship is looking this, right? That goes there, and that side goes to that angle. The bigger the side, the bigger the angle.
And because those sides are bigger, then
the angle is bigger.
that makes sense.
Okay, good. All right. So Emily, now that we're done with that, all right, why don't you go ahead and just look that over and see if it makes sense now. Okay. All right. And then I'll come back if you have more trouble. Now, Isabel, I'm sorry. Tell me which one. Good for you, girl. DE. So I'm going to find DE now. D to me is this guy right here. And then DG is right here, right? So I can't really figure this out unless I know the angles, right? So this angle right here is, what is that, 67, right? And so now 48 plus 67 is 115. So you're telling me it's 65, right? So now you should be able to tell me what? But I want you to speak up. Say it again, loud and proud. Yes, it is. Oh. No. No, look. 67, right, is greater than 65, right? So the one opposite is greater. Right? Good job. Well, that goes for everybody. Much better now. Let someone ask a question. Get it taken care of. You're smarter now. All right? Very simple. All right? Simple fix. All right? Virginia, you got any questions back there? You good? Anybody? All right. Please make sure your name's on it because I'm just going to collect it and give you credit. While you guys are getting your name on it, I'm going to pause the video and then we will start. Okay, guys, let's talk again real quick. Triangle inequality theorem. All right. There is a relationship to the sides. For example, let's look at this real quick. Someone tell me, if I gave 1 inch, 1 inch, and 10 inches, is it possible to make a triangle with 1, 1, and 10?
No.
Why?
No.
Now, some people that's easy to see, right? Some people it's not. All right, so let's look. If I were to measure something 10, and then 1, and try to do it here, and do it here, no matter how hard I try, right? I'm not going to be able to connect them, right? I'm not going to be able to connect them. Does everybody see that? So there has to be a relationship between the three sides to determine whether you can make a triangle. All right? It's very, very simple. All right? We always say that the sum of any two sides has to be greater than the third side. All right? The sum of any two sides has to be greater than the third. Now let's look at this example. Is 10 plus 1 greater than 1?
Yes.
So it looks like it's true, right? But the problem is the 1 plus 1 greater than 10?
No.
No, it is not. All right? So I have simplified the rule down to the sum of the two smaller sides has to be greater than the what?
Bigger side.
The larger side. All right? That way you don't have to go through the process. All right? You just have to look at the two smaller sides. If the sum of the two smaller sides is greater than the third side, then a triangle can be created. Now notice I said greater than. I didn't say greater than or equal to, right? It has to be greater than. And part of the reason is this. If you try to draw a triangle with two sides, and watch my demonstration here. So if I say this is 5, now what I'm going to do is I'm going to try to draw another side, right, of a triangle. If I said this triangle over here was, let's say that was 6, and I start to make a triangle, right? Am I making triangles right here, right? Yes, correct? Now, the maximum I can open up that angle is how many degrees? 180. So if I stop at 180 degrees and I said that's 6, 5 plus 6 is what? 11. So is it possible to have a triangle with 11? No, because the angle would have to be what? 180 degrees. Does everybody see that? Right? Now what I want to do is I'm going to go the other direction with it. Right? If I said that was 6 and I draw my triangle, does everybody agree that's a triangle, right?
Yeah.
Now let's look at this. What's that length right there from here to here? What's that length?
11.
It's 11. So now if I draw from A to B now, is it going to be more than 11, less than 11, or equal to 11?
Equal.
All right, hold up. If I draw from here to here, is that more than 11 or less than 11?
Less.
That's what I'm asking. Does everybody agree with that? So it's less than 11. If you can't see that, let me know. Well, think about just the rule we just created. If the angle is getting smaller, what's true about the side?
It's getting smaller.
It's getting smaller. That makes sense. Kind of like where we did what we did yesterday. So now I'm going to erase this real quick and start again. So over here, I'm at 11. So now the distance is what? Less than 11. Less than 11. Now if I go all the way over here, I'm still creating a triangle, right?
Mm-hmm.
What's the smallest degree between those two?
1.
No?
0.
0, thank you. We can say that's a 0 degree angle, right? And you'll learn that later. Just like there's more than 180 degrees. We just don't tell you that right now. But right now, I'm trying to get you to see that the biggest angle that we can create is what? 180 degrees, and the smallest we can create is what? 0. Right? So what I'm showing you is that these two lines now overlapped. It overlapped by what? 1 unit. So bear with me? Because I said one was 6 and one was 5. Hello, right?
Yeah.
So if I pull this back out from here to here, all right, that distance 1 can't be made. All right? The reason why it can't be made is because as this closes down to 0, that distance from here to here is what? 1. All right? So what we say is when you want to find the third side of the triangle has to be less than the sum and what?
More different.
Greater than the difference. The third side of a triangle has to be less than the sum and greater than the difference of the other two sides. All right, so in my situation right here, the third side of a triangle has to be less than what?
11.
11, and it has to be greater than what?
1 or negative 1.
Greater.
Negative
Well, we can't have negative 1 now. Side can't be negative.
1.
So it has to be, if I gave you this, 5, 6, and 10.9, could you make a triangle? Yes. Right? If I said 5, 6, and 1.1, could you make a triangle?
Yes.
Yes, because 6 minus 5 is what?
Negative 1.
6 minus 5 is 1, and is 1.1 greater than?
Yes.
Yeah. The triangle will just have an angle that's really small. All right? So again, one more time. The third side of a triangle has to be less than the sum of the two sides and greater than what? The difference. All right? That's all they're trying to tell us. All right? So let's see how we're doing. All right, so number 1. First of all, is it possible to have a triangle of 3, 4, and 6?
Yes.
All we do is we highlight the two smaller sides. The sum of 3 and 4 is what?
7.
Is that greater than 6?
Yes.
So that's how simple this is. Yes. Number 2, 9 plus 6 is 15. It has to be what? Greater than. So that's a what?
No.
That's a no. Obviously, number 3 is what?
Yes.
Because that would just be an equilateral triangle, right? So yes. All right. Number 4.
Yes.
Yes. All right, I think you're getting the hang of it. And then
No.
no. And then, all right, so I told you, look how simple that is. Very, very simple. All right, Now what you're doing is on 7, 8, 9, 10, you are trying to tell me what are the possibilities of the third side. All right, so the third side we're going to call is x. And it's less than the sum. So it's going to be less than what? So watch me how I'm writing this. Less than 7 and greater than what?
5.
Greater than 5. That's how I want you to write. The third side of the triangle has to be anything between 5 and 7. That's how you write it. Now notice I'm trying to tell you this just as a review from inequalities from last year. X is what? Less than 5, right? Now I want you to be able to read it the other direction. If you read in the other direction, you would say X is what? Greater than 5, right? All right. So now, number 8, X is less than 30 and greater than 6. Yes, ma'am. What's 12 plus 18? Right? How'd I get 6? That's all there is to it. All right? So let's look at number 9. So X has to be less than 7 and greater than, think for yourself, 4. Easy enough, right? All right, so here we go. Number 10. X has to be less than
90
and greater than, yeah, don't forget your calculator, some of you. All right, anybody have any questions? All right, so here we go. Let's read this. Suppose you have 3 different positive numbers in range and ordered from least to greatest. What single comparison? That's what I just talked about. What's the comparison we want to do? The sum of the what? 2 what? Smaller ones. Right? So you always just compare the 2 smaller ones to the what? Larger one. Right? So it's the sum of the 2 smaller sides has to be greater than the third side. The sum of the 2 smaller sides has to be greater than the third. All right? Like I said, very simple. Very, very simple. All right, now let's look at this. Okay, so now here's a couple little proofs that we're going to talk about. All right, even though it's not really a big deal, and like I said, I looked it over. I thought you guys would be able to handle it easily. All right. And again, this was a weakness for some of you guys, so I went ahead and just wrote down the answers here, and then we'll do another one where we have to fill it in to see if you learned something. All right, so let's talk about it. It says, given that triangle ABC is what? Congruent to DEC. All right. Now I'm going to write this down. So ABC. So AB is the same as DE, right? And then BC is the same as what? CE. And then AC is the same as what? There you go, guys. I just feel like that's good for me. All right. It helps me keep it in proper perspective. All right. So now we're just going to walk you through it here. So triangle ABC is congruent to DEC, so we say that's what?
Given.
That's definitely given. All right. Now, we're trying to prove that AB plus DE, I'm going to highlight that, AB plus DE is greater than AD minus BE. All right, so let's see what they got. So now, how do I know that AB plus BC is greater than AC? Yeah, that's exactly what we just learned. All right, so now, come on, guys. Tell me about that. The sum of any 2 sides has to be greater than the third. Now, how do I know that? Because what we're trying to do is we're trying to create a relationship between the sides of a triangle, correct? All right. So again, I knew this would be kind of hard, but if you follow along, I hopefully you feel like that's not too bad.
How did they know that A, B, and B, C were the smaller sides? Like
Oh, it's not that. It doesn't say that.
Oh,
The triangle inequality says the sum of any two sides is greater than the what? Is greater than the third.
okay.
That's what it says. All right. Now, let's just go back, just so I can show you something here. Let me show you what I mean, Charlotte, just to make sure everybody's understanding me. All right, so if we go back to our worksheet here, we clearly said this was yes, right?
Yeah.
So now, if you look at 3 plus 4, that's going to be greater than what?
6.
6. 4 plus 6 is greater than what? 3.
Oh, okay.
Because these are the two sides that we're talking about, right? The sum of any two sides is greater than the third side,
Okay.
right? Now, here, let me try to say this because I didn't say this and I think I could do a better job. Now, why don't I compare the, why do I say the sum of the two smaller, right? And the reason is because 6 is already greater than what?
3.
So if I say 4 plus 6, is that greater than 3?
Yeah.
That would be obvious, right? Because 6 is already greater than 3. Does everybody understand what I'm saying? But 3 itself is not greater than 6. So I have to compare that to the other side. All right, hopefully that helped a little bit. All right, so let's go back to our proof now. All right. And then I want everybody to be able to look at this and say that DE plus EC is greater than CD. Is everybody okay with that? Same kind of process. Now again, what they're doing here is they're just trying to make a relationship between what?
The triangle.
Yeah, the sides, right? And we're adding in an inequality symbol. Now, again, I wouldn't have known to do that, honestly. Right? That's just something I have to show you. Right? So when they're trying to make a comparison, then we know we should be trying to put in or incorporate the inequality theorem. All right? Now, AB is greater than AC minus BC. And DE is greater than CD minus EC. So how did I get from this step to this step? And how did I get from this step to this step? Well, I mean, it kind of tells you, but still, does everybody see that? Right? So right now it says AB plus BC. How did I get AB is greater than AC minus BC? All I did was I moved the BC from the left side to the what? By doing what? Subtracting. You with me now? And just like this, I subtracted EC from both sides. That's the subtraction property of equality. Everybody okay with that now? Everybody okay? All right. Now, what I want you to do is, what is this? And what is this right here? Someone try to figure it out. Come on, how did I get that? What did I do? Somebody else. Yeah. Now look, I'm not arguing with you on that. That's not bad thought. But look right here, guys. And again, I'm telling you, we're struggling here. I'm okay with that. All right, that's why I'm walking you through it. So I want you to look at this right here. I always say try to look at the previous step. So what did they do to A, B, and D, E? By doing what, though? How do we?
Addition.
We just added them. So if I add A, B, and D, E, I have to do what? I have to add all of these together as well. Is everybody okay with that? Right? Anybody have any questions? Come on now, don't daydream on this. Now, look here. AC, CD, BC, EC, we just rearranged the order, it looks like. Right? And if you rearrange the order, that's just the what? Commutative property. Does everybody agree with that? All right, now from 5 to 6. From 5 to 6, they factored out a negative, it's looked like to me, right? And I would have called this factoring, but they just say it's what? Yeah. Is everybody okay with that? They just factored out a negative. Anybody have any questions? Go.
How would you factor out a negative there?
Well, because it's negative BC and negative EC. So if I were to distribute that negative, do you see how it would be negative BC and negative EC now?
Oh, yeah.
See that now? Right? So that's what we're talking about. All right. So now, what is AC plus CD? Yeah, because that's just going back to something we did the first week of school, which was the segment addition postulate, right? So now they're saying AC plus CD is equal to AD. And the same thing here, BC plus EC equals BE. Again, that's just the what? Segment addition postulate. All right, so now we're trying to figure out the what? We're trying to figure out how we got, now look, this was hard for me to see at first, so I want everybody to look here. Does everybody see AB plus DE, right? So I'm highlighting AB plus D. Did that change? No. Now I'm going to highlight something else for you. AC plus CD. What's that? AD, right? There it is right there. Everybody see that? And now what we're going to do is BC plus EC is what? Right here, which is BE. All right. So again, that's hard. All right. I just wanted to show you. All right. That was kind of hard. All right. So now let's walk through this one right here. Let's see how we're doing. All right. So I'm sure it's not that hard to do number 1. What is that? Given. All right, so everybody take a look at that. And I'm going to write it. PL is parallel. And it says K is the midpoint of PT. K is the midpoint of PT. So I'm going to mark this right here. Everybody agree with that? Now, somebody tell me why angle P is congruent to angle T. Do you know? No. Look right here. You got to highlight carefully. This is angle P, and this is angle T. Those are not vertical. Those are what? Yeah, it's hard to see because the parallel lines. Very nice. Alternate interior angles are congruent. And now we know K is the midpoint of PT, right? Now, why is PK congruent to KT? Tell me, Isabel. Yeah, definition of midpoint. Good job. Definition of midpoint. Okay. So now step 5 has to do with vertical angles. Yes, I like that. We would say angle MKT is congruent to angle PKL. So now I'm going to mark this congruent to this. Okay, why are the triangles congruent then? That would be, tell me. Does everybody comfortable with angle, side, angle there? All right, so let's do angle, side, angle. So now, I'm having to look down here. I'm trying to compare PK and KM. Right? I'm trying to, come on, stay with me now. I'm trying to compare PK and KM. Are those equal? Are those congruent?
No.
No. Are they? Come on, look at it. Are they congruent?
No.
No. Right? So we're trying to show that PK plus KM is greater than PL. All right? So we're trying to show PK and KM is greater than PL. So I need someone to take a chance here and help me out. How do I get to that spot? How do I get to that spot? What can I say? Tell me.
Because PK is congruent.
Well, no. I want you, what I'm trying to get you to tell me is, I'm agreeing with you, but I don't want you to explain that. I want you to be able to get this in here. You know what I'm saying? Somehow we gotta work to that. All right? You want to give it? Tell me what you think.
PK plus KL equals PL, and MK plus KT equals MT.
Now, I think you're right, but I think because it's saying something about triangle inequality theorem that I have to write an inequality statement. You agree? I think what you said was true. Tell me what you think.
LP plus PK.
All right, hold on. LP plus PK
Greater than KM.
is greater than, oh, wait a minute. LP plus PK is greater than,
LP plus PK is greater than KL.
is greater than KL. You agree with that? Is that correct, though?
Oh.
What do you think?
Um,
I mean, that's true, 100% true. But what I'm looking at is I'm trying to get this,
There's more.
right? You see what I'm saying?
PK plus KL is greater than PL.
I think, hold up, come on now. I think he's correct on that, right? But again, I'm looking at this and I'm trying to tell you, hold on, put your hand up for a second. I'm trying to tell you what you are 100% that is a true statement. But that's not going to help me out because I'm trying to get to these three right here. And although you are telling me what? Although you are telling me PK is part of that, I don't see where PL fits in. You know what I'm saying? So now, go ahead. Tell me again. I'm going to erase this. And then you tell me what you thought was true.
PK plus KL is greater than PL.
Is greater than PL. Now, I'm trying to show you now. It's just something, guys. I'm not arguing with you. That's kind of hard. But how do I know that's better? Because look right here. PK is here, right?
Mm-hmm.
PL is in the right spot. The only thing I have to change is what? I have to change what?
KL to KM.
KL to KM. Does everybody agree with that? Right? So again, I think that's great. So now, all right, I'll let you jump in now.
Okay, so then you would do KT plus.
Wait a minute, you just told me a second ago. That's why I'm letting you do it. What's true about these two things?
You have to change.
Yeah, but how do I can't change them without telling me that they are what?
Equal.
They are equal, right?
So
So you would say that what? KL
it's congruent to
is congruent to,
KM.
there you go. And again, that's where we had the what?
CPCTC.
Yeah, CPCTC. Corresponding parts of congruent triangles are congruent. And then we can just do a what? Yay, we can do a substitution. All right. Now, listen to me, guys. I'm with you 100%. That was hard. All right, so look, if you want to make an A on your next test, my suggestion is you look over these two. My suggestion is you look over those two. I'm not saying you have to know how to do it. I'm not even asking you to memorize it. I'm saying if you just practice those, that'll make you better. All right, that will make you better. Is everybody okay with that? Because does everybody agree? Come on, the other stuff is what? just ridiculously easy. I really thought about even skipping this. All right. But again, I thought there was a couple good things in here for your SATs. That's why I went ahead and left this in here. All right. So now your job is to go ahead and finish this up. Notice I crossed out 18. I don't care about that. But there is a little proof. I want you to try the proof. And then try 5-5, the practice. And then there's another little proof. All right. Again, the other stuff is easy. Look over the proofs. All right. Yes, ma'am.
The last 2 pages are
Oh, are they? Oh, so this is your lucky day then. All right, I made a mistake. Yeah, boy, you guys are lucky.
Mr. Stroud, I was just looking at the proof on 117. What's definition?
Say what?
The definition of inequality.
That's saying if you draw medians, that means that it bisects the opposite
So
side.
I could just write definition.
All right, guys, I'll post this now. Good job today, guys.